So, good afternoon, everyone. So, we will start within a few minutes. So, welcome. So, I'll welcome all of you to this live interacting session. So, this is our fourth live interacting session. So, previously we have done three live interacting session. So, on these courses of conduction and convection heat transfer. So, I am your TA Niloy from IIT Bhubaneswar, and I am a PhD scholar. So, I think you have gone through these courses where Professor Chakraborty and Professor Shum is your course instructor, and they have delivered the lecture, right? So, I hope that you understand the concept, and today I am here to describe about this fundamental concept, and based on this concept I will help you to solve this assignment type question or some questions that can be asked in the gate, right? So that will be my target. So before starting, let me introduce about these courses as few of you may as this course may be new to few of you. So why we are studying this course? So we are studying this course because this heat transfer concept, maybe it conduction, convection, radiation, anything you will find in our daily life. Like in if I talk about human body, while in fever you see that the body temperature rises. So there is a fundamental physics behind this. So our main motto is to understand this concept and how to solve numerical problem which we can implement in our real life scenarios. So we will be dealing with the mainly conduction and convection mode, and along with all other laws and the governing equation that can help us to understand this concept in a depth manner. So though this is a 12th week course, so if anyone of you are interested to sit for this exam, please register by tomorrow. Tomorrow is the last day for enrollment for this exam. I hope that if you gone through these exam related courses exam, so you will get to examine your fundamental or whether you have understand these courses or not. You can test yourself. So it's better you go for this registration. Okay. So in the previous week, what we have discussed about this 1D conduction equation in a cylinder in a sphere, and we have solved the numerical. Also, the important thing is that what we have solved is based on the 1D conduction equation. So, so in the last class, what I have said that if a equation is say in a numerical problem, if you know this 1D conduction equation, which is basically in the in the partial derivative form. For 1D it is in the normal derivative form. So if you know this derivative form and if you are asked to find the temperature, what you need to do, you need to integrate it. And similarly, if the temperature profile is given, if you are asked to find the heat transfer for this 1D conduction, so what you need to do, you need to basically find out this temperature gradient, and based on this temperature gradient you can easily find out this heat transfer. So that things we have studied, and also we have solved few numericals, right? So in today's in this week, what we are going to discuss, we are going to discuss this heat transfer from this extended surface, and also we will be dealing with the various boundary condition on this spin tip. So these are various scenarios for this extended surface, and why these extended surface are important in respect to this heat transfer, that we will discuss. What are the various types of fin and its efficiency and effectiveness, that thing we will also discuss. And if the time permits, we will also discuss with for this 2D steady state conduction. Okay, so and all the main motto is that we will study this fundamental. After this, we will solve some numericals so that you will be better understand this concept. So that will be our motto. Okay. So hi Ayush. How was your exam? Hmm. So what do you predict? So what about these mathematical parts and this aptitude part? Hmm. So up to you have attempt about how much mark, like 70, 60, 50, like. Okay, so how much confident you are about your attempt, and and what is the experience? Yes. So as it is your first time and already you are in third year, so whatever may be the outcome, no need to fear, worries. You just take up this feedback, whatever you have done wrong or whatever you have done correct, and all this you think analyze, and you can go for better in the next year. Okay, because this gate will give you a platform for this PSU, and even if you goes for this MTech, there is also option and higher studies. Okay, so we'll start today's session. Okay, so these are these concept that we will discuss today. So first we will start with this heat transfer from this extended surface. Basically we are talking about this fin surface, and this is, so why extended surface is necessary. Basically in extended, if the in heat transfer, if the surface area is more, the heat transfer will be more. So you can say, how I can say this thing. So if you are looking into this, sorry, if you are looking into this Fourier equation, so what that state, this is Ka, right? So if you see the, it is Q is directly proportional to A. So if all other parameters are constant for any certain criteria, so if you increase the area, what will happen? This Q will increase, right? So one, how we can enhance the heat transfer? We can enhance the heat transfer if we can increase the area. So that can be a scenario. And next is that, say K. Basically in real life scenario, if you talk about a material, whatever it may be, copper, it may be stainless steel, aluminum, this K, which is the thermal conductivity, it remain constant. So we can't compromise with this K. So we have only two parameter left, one is A and another is the temperature gradient. So also if you increase this temperature gradient, the heat transfer will increase. But this thing you can relate to your daily life, like this first scenario where area increase, this heat transfer increase. Say if you are taking a cup of tea, right, and it is provided in a over a plate. So you observe that this tea is quite hot. So what you did, you just pour this cup tea over this plate, and you will observe that this tea will get colder at a quicker time compared to the tea that was kept in the cup, right? So that means the surface area of the tea in the cup is less compared to that over the plate. So that means if the area is increasing, the heat transfer will increase. So this is a real life scenario. And next scenario is that if we increase the temperature gradient, the heat transfer increase. For the same cases, you can say if after pouring this tea in this plate, you observe that the heat transfer rate is less. So what you will do? You will just blow air over this plate, right? So that means you are forcing air, so which is basically a convection. So what is convection? Convection is the heat transfer because of the motion of a fluid. So what is the fluid here? The fluid here is the air that we are blowing over this tea over, which is kept over this plate, right? So if we are blowing the air, what will happen? The temperature gradient will be more. That means the change in temperature with respect to change in the length or the change in the space will be more. So the heat transfer will be more. So that is the two scenario. So in our today's lecture, we will be dealing with only the first scenario, where the if the area is increasing, the heat transfer increasing. We will not be dealing with this temperature gradient portion. But that can be a scenario. Please remember this thing. So I'm drawing a surface. You see, this is a play. So this is a long plate or whatever you can. So in this plate, we are adding a fin. So this one, this horizontal extension is a fin. Let us consider this as a fin. Okay. So for your understanding, I am drawing an axis here. Just a minute. Say this is your x-axis and parallel to this is your y-axis. Okay. So this plate, if you talk about this plate, let us consider this plate is at a temperature TV. I have kept the plate at a temperature TV. Okay. So this temperature is, say I draw with a green line. This green line you observe. So this green line, in each of these point in the green line, the temperature is TV. Let us assume it as TV. So this is the temperature of the base surface. So why I am drawing all these things? So if you basically look into this in your fridge, if in your I hope that all of you have fridge in your home. So in the back side of the fridge, you can see some types of these types of arrangement you will see in the back side of the fin, right? Have you seen these types of structure? So this horizontal line basically is the extended fin. So their main purpose is to enhance the heat transfer so that the heat can be easily released to the atmosphere. Okay. So this scenario I am just recapping this into a smaller portion. So in this section, say I am taking a small portion, say this small portion here. This is the small portion I am taking. At this point, what is the temperature? This is at TV, right? Just 1 minute. For better understanding, I am doing one thing. See, this is your Y. That will be better understand. So this point, this is your origin, right? So this small portion, this is your del x, and which is at a distance of x distance from the origin. Is it clear up to this? Is it clear? Hmm. So the total length of the fin, let it be L. Total length of the, right? Hmm. Now you see, if I draw this fin in this small region, so it will be looking like, yes or no, like this. So this is your del x. So what will happen if heat is already there is temperature TV. So if the temperature moves in this direction and this is atmosphere. So say it is at T infinity. Say this is at T infinity, the outside air. So what will happen from this section there will be heat loss in the top portion which is Q convection, right? And similarly from the bottom there will be heat loss. So if you see here there will be Q convection, from the bottom also there will be Q convection, or similarly the heat will flow in this direction due to conduction. Yes or no? Please tell me if it is clear or not. In this direction it is Q conduction. So I represent this Q conduction as Qx. Okay, this is your conduction. Similarly, in this direction there will be also conduction. So I represent this as Qx plus del x. You can put dot here. So that means the conduction the heat is conducting through the small region x, and if this x will increase, this heat conduction will be like that, it will increase. So we have the energy conservation equation. So what I can write from here, can I write qx, the heat conduction in this region, that should be equal to heat conducted out of this region plus q convection total. Have you got this? Yes or no? Just tell me. Hmm. So up to this it is okay. So for your quite understanding, I write conduction, comma conduction. Okay. So just you tell me few things. What is the formula of Q convection? Can you remember? H A? Hmm. H A. Huh. H A A T minus T infinity. That is the equation. It is correct. But why I am not writing area here? Say it is talking about a fin, right? So in this fin, we know this del x is there. So basically we have to represent this area in terms of perimeter and this. So what is the perimeter? I represent P perimeter into del x, I can write as area. Area is P into del x. P is the perimeter. So convection is happening from the top surface, right? So if you find out this perimeter here, this line and this line, to into this line, say this is the length. Let us only assume that the heat transfer through convection is happening from the top surface. For a moment, assume heat is transferring only from the top surface. So we can take this length, total perimeter into del x should be your area, right or wrong? Achha, for your convenience, I can say if it is a cylinder, that will give you a better understanding. Can I write the area of the cylinder should be circumference, that means perimeter into height. This cross section area I can write now 2 pi r into h. So similar thing is happening, perimeter into del x. Is it clear or no? Just tell. Hmm. Okay. So that is the thing. So Q convection I got. So I can write in place of Q convection, I can write this equation as like this: x conduction minus Q x plus del x conduction equal to Q convection is H P del x T minus T infinity. Okay. So now I am dividing this thing by del x on both sides. So what I will get, just a minute, sorry, little mistake I have done here. Just I have put the value here. So can I write qx plus, I just take this left side q on the right side, del x conduction minus q x conduction plus hp t minus, I divide the both side by del x. Can I write this form? Hmm. So what basically this term is? So in mathematics you have studied, I hope, that this is a derivative. This is the formula of derivative or differentiation. You remember dy dx is limit x tends to 0 function of y plus del y minus function of y by del y. So that thing you have studied in class 12, even in BTech. So that, so I can write this as this format. Hmm. So just I have write h p, p is the perimeter, remember, t infinity, this is 0. Up to this any confusion? So hmm. So now you tell me one thing, that uh, this is gone. Just tell me one thing, this q dot x, what basically it indicate? What is q dot x conduction? Heat due to, so what is this formula? Yes, good. Conduction I can write is minus k a dt by dx. So what is the a here? Can you tell? Which a, perimeter into the, or more precisely I can say, see, why this perimeter I have written, because this perimeter in case of convection it is on the top surface, that's why I have written it as perimeter. Okay, my purpose is to form this thing del x, so that's why I have written it as p. It's for understanding purpose. But here the area, in case of conduction, the heat transfer, we will take only this area, right? Cross section area is there na, so I just take this cross section area as a, or ac, this area as ac. So now this equation will looks like d dx of, in place of q I can write minus k ac dt by dx plus hp t minus t infinity, right? Say in, for a material, if ac is constant, k is constant, so I can write this equation as like this form, minus k ac d square t by, yes or no? Hmm. So up to this I hope that there is no confusion. So I am erasing few part of it. So I consider K and AC as constant. AC is the area of the conduction. Remember this difference between the area. One area is the area due to convection and another area is the area due to conduction. So this convection and conduction equation may be same, may not be same. So please remember this thing. So now this thing can I write? I'm using another color. So this equation can be written as d squared t dx square minus hp by kac t minus t infinity. Just check. Hmm. So this is okay. So I am moving to the next slide. Just remember this equation. So what I have got, d square t dx square minus h into perimeter. What is h? What is T infinity? What is T? No, base temperature is TB. T is temperature at this point. Anywhere at this point. This is the surface temperature of this block, TB. Okay. So T is unknown to us. Just remember. So I just take for simplifying this equation, let us consider T minus T infinity as theta. Right? I just consider. So if I derivative it, what I'll get? This T infinity is constant na? So double derivative of it will be, yes. And one thing I have considered that this HP by KAC, this thing I consider as m square. M is a number or a constant. So what basically is m? M means root over, just remember this thing, HP by KA. So that is our m. M is a constant here. So this equation I can write na disk in place of double derivative of t I can write as, can I write? Please check and tell me. Hmm. So this is a second order derivative. This is a complementary solution you have studied in the derivative part. You remember this complementary solution? So if an equation is like this form, so I can write this as, what is the coefficient of this derivative term? This is 1 minus what is the coefficient of first derivative, whether this is a second order derivative, so its coefficient is order, coefficient is 1. What is the coefficient of the first order derivative? Whether any first order derivative is there? First order derivative means my dt d theta by dx. So no, and the what is the coefficient? So you write down the all these coefficient of this term. This equal to 0. So what will be the m? M is plus minus 1. Okay. So the solution, its solution in maths you will definitely find, if an equation like its solution should be c1 e to the power mx plus c2 e to the power minus mx. Okay, this is not m, so you just have to take it other thing. Okay, So take it as D. So this D basically indicate this symbol, whether it is -1 or -2. You got it? Hmm. So our main, whatever we have understand till now, our main funda is to remember this equation, nothing else. So we have to remember this equation. So that will be our equation. Up to this, I hope it is clear to everyone. Now, this is the equation. What is theta? If someone asked what is theta here, basically theta is t minus t infinity. Or if someone want, they can write in this way, they can write. But better to remember this equation. Please remember this equation always. So that will be same for every fin type or extended surface equation, right? Now, what is the problem here? The C1 and C2 are not known, but M is known. What is M? M is root over of Hp by Ka. H is the heat transfer coefficient, P is the parameter, K is the thermal conductivity, and A is the area of the conduction, from where area perpendicular to the section where heat transfer is happening due to conduction. So this is the equation. Now I am writing this, see in the previous slide. Just remember one thing. So I am erasing all thing. So this derivation may come in your exam. So this is quite important for exam point of view up to this derivation. So there are certain boundary condition. So up to whatever we have derived, this is the temperature. So if you have to find the temperature at any point in the fin, so you have to use this equation. So we got theta as C1 e to the power mx plus C2 e to the power minus mx, where theta is T minus T infinity. T is any temperature at a point, infinity is the surrounding temperature. M is Hp by K. Okay. Now what we need to do, we have to consider boundary condition. So what can be the boundary condition? So here the variable is T. So in this equation, what are the variables? Basic main variables is the temperature or theta you can say, and X is the variable, right? So boundary condition can be X is at origin, X equal to 0. What will be the temperature? What should be the T? TB, right? So I can write, so theta can be written as theta B. Okay. So if x equal to 0, this equation, let this be equation 1. So this equation 1 can be transformed into theta equal to theta B. So here I can write as, in place of theta I can write theta B, and x is 0 means e to the power 0 is 1. So that is C1 plus C2. This is one boundary condition. Is it clear? Others? Is it clear to others? Okay. Please let me know in an interval, or else I will not understand whether you are really understanding this complex problem or not. So, how many variable here? C1 and C2. Two variables are there, unknown parameter I can say. But see, this TB means temperature is given at the base, T infinity is known. So indirectly I can say that theta b is known. It's a known parameter. So what are the variables? The main unknown are the C1 and C2. So to solve an equation having two unknown, how many equations are required? Two equations are required. So this is one equation, right? So I need to find out another equation. So how I need to find out? So see, this is at x equal to 0. So that means at x equal to something there should be another equation. Okay. So in this question, if it is given that the infinitely long fin, that means this fin is quite long. So I can write here, that means x is infinity. That means this length is quite long. So if x tend to infinity, what should be the temperature? Yes, very good. What is T infinity? Yes, surrounding temperature. Good. So so therefore this theta, in place of theta I can write as theta infinity. So what basically is theta? T minus T infinity. So in place of T I can write T infinity, which is basically 0, right? So here the equation 1 can be written as, in place of theta it is 0, and this is C1 e to the power infinity plus C2 e to the power minus infinity. What is e to the power minus infinity? That means 1 by infinity. So more precisely I can write this as C e plus 0, because 1 by e to the power infinity, e to the power minus infinity is 1 by e to the power infinity, which is 1 by infinity, that means 0. So that's why I have written this as 0. So more precisely I can write C1 as 0. I think you got it. So what is C2? So I have to put it, if it is equation 2. So from equation 2 I can write theta b is C2, right? So equation 1. So I have found out C1 and C2 both. Now I have to put it in this equation. So this equation, what is C1? C1 is 0. So this term will not be here. So C2 is theta b e to the power minus mx. So see, our equation has been simplified to this format. So in book you will find this as, right? Ayush, is it clear? So that is our equation. So I am erasing few part again. Where? So what is theta? This equation, if I write, this equation is t, theta means t minus t infinity, theta b minus tv minus t infinity is e to the power mx. So you can find out t from here. If someone asks what is t, you can easily find out t. Okay. Now, So we get our temperature profile. If someone asks you to find the temperature, you can easily find out temperature, but just they will have to say at what point. At x is what? That means the distance of the fin from the origin. If it is 5, so you have to find out this thing. What should be the value? Now my question is that what is the heat transfer? The temperature you got, then what is the heat transfer? Please tell. How we will find out the heat transfer? Huh, yes, that is the formula you are saying. But in real life, how you will derive this thing? Whatever you say is correct. But I am saying how you will derive this thing. What is I have said Q. You are asked to find Q. How you will find out this Q? Yes, yes, very good. Because this is a long fin, so we have to find this is our conduction equation which is KAC dt by dx. So in see one thing, what we have got, this dt dx or d theta dx both are same, right? So you can find out this thing here at, I can write x equal to 0. So I have to find out what is the heat transfer at this n. Hmm. Say from this equation, this is your equation 3. I can write now d theta by dx, what it would be. From this is 3, sorry. So I can write it as minus m theta v minus mx, right? So that will be the format. So I can now it is at d theta dx at x equal to 0 should be minus m theta v. So that means this and this are both the same value. So I can write minus KAC plus this m theta v. So what is m? M basically was root HP by KAC, and theta v means T b minus T infinity. So it basically you will get Q long fin root HP KAC. So always the best thing is that remember only this equation, equation 3 or the below equation. So that will be the best because there are certain condition and many equation are there. So always it is quite tough to remember all these equation. Students are getting confused. Okay. So if you understand this thing, you can find Q long fin. And some students have exceptional remembering power, so they can remember this thing, not an issue. But that is the fundamental. Okay. So can I move to the next case? Okay. So the next case, what is the this case? This case is for long fin. That means the fin is long. This was the scenario, right? Now I am moving to a new scenario where the condition is adiabatic fin tip. That means no heat loss. say you, if you remember this thing, I am drawing only the 2D view. So that means in this region there is no adiabatic, means there is no heat loss, right? So I just moved to the previous form of the equation. So what I have got, theta is C1 e to the power mx plus C2 e to the power minus mx, right? And the first boundary condition is at x is equal to 0. Yes, yes. So more realistic in terms of physics, what you can say? No heat loss means Q is 0. Uh, so what does Q is 0 indicate? Huh, huh. In real life scenario, K cannot be 0. So that's why. Okay, good. I I wish you understand this thing. Hmm. Yes, yes, good. Yes. So that means here I am giving a length, a diabatic fin at a length, because it is not infinitely long. Now it is at a length L. Okay. So this is adiabatic, means this is the boundary condition here, right? So the first boundary condition, it at x equal to 0, the t is tv. So more precisely I can write theta is theta v, which is tv minus t infinity, the previous case. This is nothing new. So I can write theta v is c1 plus c2. So this boundary condition is same in every any condition or any case. Please remember. One, this is your two. Now the boundary condition is, in case of a derivative fin at x equal to L, dt dx x equal to L is 0. So now how you will solve this thing? Can anyone? How you will solve this thing? Anyone? So see, at x equals, so I have to put here the condition is dt dx. So most precisely I can write dt dx or d theta dx, both are same. I have proved earlier, right? See, so this is your theta. So now I can find out d theta dx from equation 1. What should be this? C1 m e to the power mx minus C2 m e to the power minus mx, right? Everyone, is it clear? E to the power minus ml. So that is the condition. What is its value? It is given 0 at L. So I can write 0 is C1 m e to the power ml minus C2 m e to the power ml. So you can put to uh, someone mic is on. Can you please? Okay, thank you. Hmm. So that is the equation 2 and equation 3. So two variable x1 and x2 here, sorry, c1 and c2, here c1 c2, you can easily solve, right? So this derivation is quite important because it may carry a question of 5 to 10 marks. So this c1, if I have to solve, in place of c1 from equation 2, I can write this as theta b minus c2, or c2 m any confusion up to this. So c2 you will get theta b e to the power ml by, okay. So similarly you can find c1. I am not finding out the c1. Please let me know. Ayush, okay. Hmm. So C1, C2 you find out. So after that, so why I am saying you just remember the format, how to solve, that is important, not the final answer is important. So first boundary condition you see this is common. The second boundary equation, this is why I am saying sometimes student only remember this formulas that has been given like this. If you talk ask them what is the equation, they can easily say that t minus t infinity by tv by t infinity. So here the final equation, if you after solving, you will got theta by theta b. This is, anyone solve this one? Cos m, sorry, cos h, hyperbolic function L minus x by cos h ml. So many of you just recall or remember this equation, right? Yes or no? Yes, sir. Okay, then say if in any question, say this value c1 c2, this thing the equation 2 you got, and this boundary condition, the value of m l and everything is given, so you can easily find out this value, m value easily find out. So at that cases this equation may be quite looks quite easy, such as just I'm giving one example, such as in one scenario if you got this e to the power ml as 0, so then no need to go here, right now. So that's why this thing is equal. Also in the question, if in gate or in short type question, so say for an adiabatic fin tip, what should be the boundary condition? That means at this is the boundary condition. The question is only this, but student is not able to answer this because they are not understanding this thing. So that's why this fundamental concept is important. Now just remember one thing, so that the final equation that can be obtained is this one, right? So how you will find out q fin? Similarly, this should be minus K A dt dx or d theta dx at x equal to 0. So in the like the previous way, you can find out. Okay. Hi. Yes. Yes. What happened? Mouse is not working. Hmm. So that is the scenario. So main thing is that you remember only this theta by theta v. So we'll join. So right now, who is answering this question? Can I know your name? Okay, okay. Thank you. Okay, that's great. And it's just course of sir. Hmm. 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 Okay. Okay, okay. Yes, yes, yes. So you are in which year? Third year or? Okay, okay. Oh, yes. Okay, that's great. Oh, okay, that's great. That's great. No, no, I am from IIT Bhubaneswar. I am in the final year of my PhD. Huh. Huh. Yes, actually, I am a PMRF scholar. So, all the PMRF scholar across the country. So, if someone is wishing to do this life interesting session, the NPTEL is giving them opportunity. So, I am one of them. Yes, 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 yes. Okay. Huh. Okay. Okay. Hmm. Okay. That is very tough. And I hope that you are in QIP, na? Eh, Okay, that is, yes, yes, I got it. Okay, 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 that is great. Uh, Anyone having any confusion? Okay, so basically, this thing, just a minute. So what up to this, what we have got, this is, so I am talking about this thing. So yes, yes, huh, huh. Yes, 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 yes. I will provide you with this previous year question after this class, because there will be a link from this NPTEL site where you will find this link, this question. Even I have shared the last question in previous year with solution. With solution. Oh, yes, yes, yes. That has been already uploaded in the last three class question also uploaded. And after today's session, I will be uploading this like this previous year question. So you will get it in the link. Uh, Not in the course login. Actually, NPTEL has already shared this video lecture of the video lecture means this live interacting session video lecture. They have been. Uh, yes, yes, yes. Along with this video YouTube link, another section. Yes. Yes, yes. Hi. Yes, 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 yes. Yes, yes, yes. Okay. So now another important thing is that for this course, you need to know this derivative and you should be good in derivative and integration. Like if I talk about this derivative of cos x, you can say it is minus sin x, and the derivative of sin x is cos x, but it is an hyperbolic function. So the derivative of hyperbolic function is same as that of the normal one, but there is no such positive or negative sign. Like if I talk about this ddx of sin hx, this is cos hx, ddx of cos hx is sin hx, not minus sin hx. Similarly, ddx of tan hx, this is okay. So this thing, just remember this thing. Just one case I am solving. This is what was given here, cos h m L minus x by cos h L. So that was given here, right? Yes. So please remember this thing. Recall this because that can be needed in the exam or for solving numerical. So now can you tell which are the constant here in this equation? Which are the constant? So this question is for Ayush. Ayush, in this theta by theta b, which one is constant? Theta v is constant. Okay. And in this part, M and H. No, M and H are constant, yes, but this X is variable. In the denominator, it is fully constant. So these two are constant. So always remember whatever are the constant here. So if I derivative this d theta dx, what I will get? This I just put it here. So that will be it is constant. Similarly, cos h ml it is constant, so it will come out of the derivative. Only I have to derivative cos h m l minus x. So that will be sin h m l minus x into minus m, right? Yes or no? Is it clear to you, Ayush? Hmm. So that means if I write it at x, so that thing I can write m theta b. This will be sine HML by cos hyperbolic ml. So that is minus theta b tan HML. Okay. So that thing I can put here. So minus KAC into, this should be plus theta b tan HML. So in the previous case, for Q fin infinite case, what is the value? H E. Can you remember? This is for adiabatic n. For infinitely it was minus KAC HP theta b. Huh? Right? So the basic difference is that in case of a adiabatic n, tan HML term is there. So please tell if any confusion. So in the GATE exam, question comes that what is the ratio between these two? Say for two cases, for a given question, two cases are given. One is for an infinitely long fin and another is for an adiabatic end fin. So you are asked to find what is the ratio of the heat transfer in the both cases. So that basically the main difference is this 10 hyperbolic ml. So that is the main difference between these two terms. So maybe it is greater than or maybe it is less than. So we can't know. It depends on this value of whatever the value of ml is coming and what is the final value of 10 HML. Depend on it, we have to say which cases will give the better result. Okay. So I am just giving you a question based on up to this. So let's see whether you are able to understand this concept or not. So this is the question. So first you have to understand what is the case in which right now I have given you three cases, right? No, two cases, sorry. So these two cases, among these two cases, which one is the case applicable here? You first have to find out this thing. So the question is that thing, how can it be an assignment question? Because that was a pre. Hmm. But this was previous year question, so I think most probably they have repeated this one. But maybe similar question, maybe. Okay. Huh. Hmm. Yes, yes. Hardly there is repetition of question. Okay. Hmm. Okay. Just a minute. So see, this is a too long in this question. Already, whatever is given in this question that has been represented by this pictorial, right? So here the base temperature is maintained at 100. So better you write down what is given initially. That means your TV is given at 100, right? And what is T infinity? T infinity is 20 degree. So if I say this theta is T minus T infinity, and what should be the theta be? So whatever I know, I'll write down this thing. This will be your 80, right? So now the question is that both are exposed to the same ambient temperature. I mean, in both the cases, the theta b should be, or the theta b should be same. Now at x a and at x b, the temperature are same. So you are asked to find what is the thermal conductivity of the rod B, because the thermal conductivity of rod A is already given. That means A is given as 70, and you need to find kV. So it is which case? Can you tell whether it is the case of infinitely long or it is the case of adiabatic end? Ayush, in anywhere it is written adiabatic. So it is written long. What do you mean by long here? Long means no length is given. So that means we have to assume it is an infinitely long. So for infinitely long, what is the temperature profile? Theta by this is not adiabatic. Not in this question, nowhere it is mentioned adiabatic. But a small hint, it is long. Long, we can, in that case, we have to consider it as an infinitely long, because the length is not given. If the length is given, then we have to think of other scenarios. So that's why it is an infinitely long. So what should be theta by theta b? It is e to the power minus mx, right? So that is our solution, temperature profile. So, or more precisely, you can write T by T infinity, whatever you want, you can write Tv by T infinity is e to the power minus mx. Okay. So now I have to find this m. So see, what is m? M is root hp by kac. So this is here the question. In this question, the thermal conductivity is different for both rod A and rod B, right? So I have to put for MA, for the rod A, it should, what should be the value? Please try to solve. See, in this question, eh, already it is given that K is different. Neither there is any details about P, AC, nothing is given. Yes or no? I wish. So just tell what you think. Huh. So Huh. So that means here this is inversely proportional to 1 by root k. Why I am writing this thing? In this equation, what are the constant? The theta b is constant for both the case, right? What are the variable? M is variable, X is variable. So I can write now theta for case A, sorry, I can write theta proportional to e to the power minus m x. So in that case I can write theta case A by theta case B. This should be e to the power minus m a x a by e to the power minus m b x b. Is it clear? So Biplobji, it is clear. Uh, So see, another important thing is that at xa at xb, what is given? The temperature are equal. That means theta case A and theta case B are equal, right now? So theta case A is theta case B because as T case and TB case both are equal. So that thing it will be, so I can write e to the power minus MAXA or e to the power minus MB XB both are equal. So or I can write MAXA MB XB. So I think up to this it is clear. So now I have to write what are the question? I have to find this thermal conductivity of rod B. Just a minute for better understanding. I am just erasing this thing because space is limited here. So I can write MA by MB. This is XB by XA. Please remember this thing. So that thing I have got. Now here from here what I have got, M is inversely proportional to root K. So I can write now MA by MB root KA by KV. So what is MA by MB? This is XB by XA KB by KA. Now all the values are given. Please solve and let me know what are the answer. Yes, it's option C, 17. Okay. So I think this question, you understand this? The main thing is that this sound are coming. Please mute your mic. Please. Thank you. Huh. So we have already studied two case. Next is another case. Another two case I am just in these cases. This is case 3. What this case is? This is that the fin is fin. Yes. Hello. Hello. Hi. Yes. Huh. Hi. Yes. 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 Huh. Huh. Okay. 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 Yes. Yes. No, not an issue. Not an issue. You just try to solve and let me know. Okay. Hmm. Huh. Yes. Yes. I will provide you with my mail here. So please write down. Okay. 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 I'll send you my mail ID. Okay. Huh. So the third case is the specific temperature. Say here a temperature is given. Third case is the specific temperature at fin tip. That means at this point if the temperature is given at TL, okay, L. So the boundary condition is that at X is L, T is TL, right? So what is theta? Theta equal to theta L. That means TL minus T infinity, right? So initially the equation was same, that theta is C1 e to the power mx plus C2, that these all these things are equal and same in all these cases, and that x equal to 0, t is tv, theta is theta v. So that thing is same. Just after solving these cases, I am not solving this thing, so you please try to solve at your home. So the main answer that you are getting here, that would be, that is important. I am writing theta by theta b. This is a quite lengthy equation. Just let me check this equation. Even I do not recall this equation always. Mhm. That equation I am not able to write the equation. Sorry, the equation is theta L, sorry, so the equation is sin h mx plus sin h m L minus x, this by sin h ml, this into I think there is a theta L. Please check the equation. Do you have books? I have to check. Huh, huh. QL upon QB into sine. Okay, yes, 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 you are right. So that is theta L by theta B. Now it is correct. Theta L by theta B sine H. So this is the equation. Please remember. Only remember this equation, because that Q equation, if you want, you can remember. But this is the main important equation. That is for a specific temperature at a fin tip. Okay. And our last case for today. This is case 3, where convection from fin tip. So, Ayush, can you tell the scenario? What is the boundary condition at x equal to L? What should be the boundary condition? Hmm. There is convection is happening. Say it is at H temperature, T infinity H heat transfer coefficient and T infinity. So here convection is happening from this end. So if the convection is happening, why the convection is happening? Because heat is conducting from this surface. So what should be the boundary condition looks like? Huh, huh, T infinity not. This is convection is happening. So that means conduction is equal to convection. Q conduction, Q convection, right? What is Q conduction here? Minus K A dx at x equal to what? L. This equal to H. This is AC. This is also AC. Now I write AC. Hmm. T should be here TL na. This temperature is TL. So this is the boundary condition. Using this boundary condition, you will get an equation, and that equation is theta by theta B. This is a quite lengthy equation. Even in my BTech, I always forgot this equation. H by mk cos, then it would be sine m L minus x. The below one is same, only x should not be there. So I am not giving you this equation for Q, because I hope that you understand this thing. So boundary condition is clear to you. So in this equation, please remember, or no need to remember, I will tell you. You just go through it. Right now it is not required to remember. Plus, but in the in your house, you just try so many problems that this equation can be easily understood. So I suggest you always remember this equation in terms of theta by theta way. Okay. So I am giving you this question. So right now you understand this thing. First, what is given here? Hmm. So what is the question here? The question in this question, understand what is this case here. It comes under which case? Uh, Constant temperature, not constant temperature. Okay, so you are thinking that the one end of the fin is maintained at 120 degrees centigrade and the remaining surface is exposed to the ambient air. So it basically, the meaning of the sentence is a little bit wrong. Actually, it is talking about the end, base end. This should be base end. The what is wrong? Somehow this is talking about the base end. Now you got it. So which case it is? Uh, Convective. So it is case of convective. Heat transfer at end, right? So what should be theta by theta v should be cos h m l minus x. Please let me know if I am wrong. Sin h m l minus x plus cos h ml plus sin h ml, right? Now I wish tell me which part of this equation are constant. In this theta by theta b, which is the constant? Theta b. And in the next part, which part is the constant? That means the whole denominator is constant, right? This constant. So in the question, what is given, that is important. So in the question, the heat loss from the fin, that means Q fin you need to find out. So I know that Q fin is minus K A dt by dx at x equal to 0. So now I just shift to derivative. So what should be d theta by dx? What is happening? Cos h ml plus h by ml sin h ml. This constant I can write. So I was tell me what is the derivative of this one? Sin h, and just tell the full derivative into what? Minus m. In this part, h by ml is constant. Similarly, it would be cos h m l minus x to minus m minus ml. Sorry, right? So so I can write ml. What is m? So all the values are known na. At x equal to 0. What is theta v? Theta v is base temperature 120 minus 20. That should be 100, right? Sine h ml plus h by ml cos h ml plus cos h ml plus h by ml sin h ml. So you can find out m. What is m? Ayush, this one is important. M is, so what is P here? This is a fin having diameter. So the fin uh, so perimeter should be 2 pi r. Diameter is given, so I write it in terms of diameter. That would be good. Pi d. What is area? Pi by 4 d square, not r square. So that is P by A should be 4 by d. H into 4 by d. So you have diameter. Diameter is given. I am not solving this thing. Okay. Diameter is given. H is given. K is given. So all these three things are given. So you can find out M. Yes or no? So so this M you will get. So you can put M here, and L is known. L is given as, I just converted into meter, 0.1 meter. So L is known, M is known. So you can find out this value dt by d theta. So you get K is known, A is known. So you can easily find out. Can you find out? Uh, so basically in this way you find out. So the answer, I am not going into this answer. So the answer would be option B. Okay, if you solve you will get the answer option B. So I think that this approach will be easy to right now. Say if you remember this, just I am showing you this example. So you see here I am giving the direct formula of Q. So if you remember this thing, you can feel that you can easily solve this question. Yeah, that can be a point. But in the exam, you have to remember a lot of concept and lot of equation. At that time, it is quite tough for many of the students to recall this thing. So that's why I just gone with this approach. This is a if you remember this thing, you can easily solve each and everything. But if you know Q, you cannot find out the. It is quite tough to find out this temperature profile. Okay. So, so another concept. I'm just moving into another concept. Erase full page. So the another thing is that fin efficiency. Fin efficiency. That is quite important. So this fin efficiency we represent as eta fin. Okay. So what basically it is? It is Q fin by q fin max. So what is q fin? Q fin means the actual heat transfer from the fin. That means right now in the previous question, whatever we found out, that one is the q fin actual. And if you talk about this q fin max, it is if the entire fin is at a base temperature. Like if I talk about this thing, I'm giving you an example. Say this point is at 100 degree. If this point is also at 100 degree, this point is also at 100 degree, this point is also at 100 degree, at that case you will get the maximum q fin. And the previous case is our real life scenario. That means if it is at 100 degree, this point is at say 90 degree, this is at 80 degree, this is at 70 degree. So there is a temperature drop. So this condition is equivalent to the numerator and this condition is equivalent to the denominator. So is it clear? Hmm. So if you remember Q and fin, it is an equivalent case now. See, if this thing 100, uh, but it is a if you say it is an unfin case, it is not fully correct. It is a partially correct. Why I am saying this thing, I will give you this explanation right now. So say if this q fin, in case if I talk about this infinitely long fin, the that q fin formula, if you recall, that is minus hpkac into theta b, right? Huh. So now this is the maximum temp. Say if it is what I am said, T fin max means if it is at TB, this point should be at TB, right? So that means the heat transfer from the fin should be only because of convection. So if it is because of this convection, so this Q fin max should be H area of the fin into TB minus T infinity. That means H A fin into theta b. Is it clear? So, huh, from the end. So, what is Q fin max? Q fin x means across all the point throughout this fin, the temperature is same as that of the base temperature. Please remember this thing. And Biplab ji, so what your question? Why I am saying in your question, if the say if the fin is like that, so the in that cases the area should be the area of this. This is a converging fin, right? So here the area of the fin is smaller than the area of the base. Is it? Hmm. So in that cases you can't say na that this if you take this area of the base, then unfin, it will not be correct at that case. But your cases is correct if the fin is having equal uniform cross section. So better please remember this concept as this fin max means the means the heat transfer from the fin if all the fin if the throughout the fin the temperature is same as that of the base. Irrespective of cross. So if you put it here, these two things, this one and this one, you will get this as I am directly writing If you solve, you will get 1 by ml. Okay, so I am not deriving this thing. If you just divide by this thing, this theta b and theta b will be cancelling out, right? So in this way you will get. And here in this case, in a particular case where the cross section is same, this A fin and AC are same. So why I always suggest the student to remember the fin efficiency this formula, not this formula, because student often get confused. If the area, if the cross section area is varying, at that case this formula is not valid. This formula is only varied when the area of the fin and the area of the base should be same. Okay, so please remember this formula only. Okay, so I am moving to the fin effectiveness. Hmm. This one is fin effectiveness. So previous one is the fin efficiency, now it's the fin effectiveness. What is basically the fin effect difference between these two? Fin efficiency basically it indicates how much efficiently the fin is working. But if in case of fin effectiveness, actually it also give you the indication whether if you are implementing more number of fins, then whether it will actually help to enhance the heat transfer coefficient or not. Maybe say if you are adding 10 fin, the heat transfer coefficient increases. But if you are adding 12 fin, the heat transfer coefficient is almost same as that of the 10 fin. And if you are adding 20 fin, the heat transfer coefficient somehow decreases. So there is not this effectiveness give you a scenario, say how much fin is required to get the best effectiveness, to best result. Okay. So fin effectiveness, we represent it as fin. So this fin, this is heat transfer rate from the fin by Q from the base area. So it is actually the heat transfer from the surface of area AB by, sorry, this is heat transfer from fin of base area of a fin. Like in these cases, whatever Bipluji said that unfin surface, so you can consider it here. So basically this thing you can write H AB TV minus T infinity. So it is for these cases I am giving you two examples. So this is the first case. So you can find q fin, right, from the base, which is minus ka dt by dx at x equal to 0. So this is the q fin you can find out, and qab basically means only this thing. There is no fin or unfin. So only this section you will take here. T B, sorry, AB, area B. So you understand the difference, or more precisely I can write it as Q fin by Q no fin. So is it clear? So I am moving to the next question. So this is a question. This is a simple question. So in this question, a cylindrical pin fin of diameter 1 centimeter diameter is given. So diameter is given 1 centimeter. So convert it into meter. Length is given. So the negligible heat loss from the tip has an effectiveness, fin effectiveness, that means this value is given 15. So base area is given 250, T infinity is given 30 degree, H is given 85. So what is the heat loss from this fin? So how will you solve it? Can you tell me? Heat loss from the actual fin, yes. Q, you have to find the Q dot fin. Huh. Yes, yes, good. Huh. Yes, yes. Q no fin. So basically Q fin is effectiveness into Q no fin. What is Q no fin? That means it is purely because of convection, which is H E. Yes, yes. So if you put, you will get the answer. Please let me know what is the answer. Okay, okay, not an issue. So that is the fundamental. So no need to tell the answer right now. Yes, yes. Just a minute. What I'm checking? What is the answer? Let me check the answer. The answer will come option C. Though I haven't solved it. Okay. So I am moving to another such types of question. Hmm. So this is a question, you see, please read this question initially. So in this question it is said that this is an heating element. So this its diameter is given, external diameter is given. So there is some round fin along this tubular surface. So it's how it is given. all other parameter is given. The space between the fin is 7 mm. So the space between two fin is 7 mm, and there are 100 fins and 100. Okay. Same question or value is different? হ্যাঁ, আচ্ছা, ওকে। হুম, হুম, হ্যাঁ, yeah, yes. Yes. So that is the thing. So there is 100 fins they are given. So this is the important thing. Please highlight this important thing. And 100 interfin spacing. That means this spacing they are talking about. There are 100 such spacing and 100 fins. And the T infinity is given. Heat transfer coefficient is given. Efficiency is given, not effectiveness. That means N fin is given as 0.98. Okay. So steady state and constant thermal conductivity is constant, it is given. So the first question is the rate of heat transfer from a single fin. Okay, so how to solve it? So you understand this question? Please check the question once. So for your understanding, come on, see, I just copy it here. Come on, V. So I have the question with you. So the first question is, what is the rate of heat transfer from a single fin? Q single fin, right? So you know this formula basically, which is the convection heat. Why is the heat flows? Because of convection. That is known to you. The formula is HQ T base minus T infinity. That is you know. But the main thing is the area here. What is the main thing? Main thing is the area. So if I talk about a single fin, okay, single fin. So what should be the area? If this fin I am talking about, so this is the fin, right? So its internal diameter is 3, outer is 3.5 centimeter. So the area, what should be the area of the fin from which the convection is happening? From this surface convection will happen, yes or no? Hello. So this surface is on both sides. This is top one, bottom one, there is also surface. So that means if this is a 2, if I find out this area, pi by d, pi by 4, but it is in centimeter, so we have to convert it into meter. So why I am taking 2, is it clear? Because one is from the top surface, one is from the bottom surface, right? uh, so next is also the heat convection can be happening from this edge. That means this surface from the blue line, right? So for this, what will be the area? This is like a cylinder. So in the question, it is given It is given. Let us check 3 mm. So it is 3 mm. So that should uh, yes. So it should be your pi into diameter is 0.035 into what should be the it should be 0.003. Okay, is it clear? Pi d into h. Pi d h. Huh, okay, so that is the formula. So you will get this total area. So please calculate, you will get an area, right? And based on this, you can easily find out this Q single fin, which is H A single fin into TB minus T infinity. Hmm. Yeah, yes, yes. See, uh, this is a fin, right? This is the top view of the fin, this region. If you see from the top, this is the fin you observe now. So what is this area? If the outer diameter is say R2, the inner is R1. So what should be the area? Pi R R2 square minus R1 square. So this surface, this is from the top you observe. From the bottom also the same surface is there na. So this is from the bottom also. So that's why into 2. Good. So now its height is say h. So this is the surface also which is participating in the convection. So as it is participating in the convection, so this q is sorry, this area is, this is a cylinder looking like a cylinder na, pi d into h, or I can say pi into 2 r 2 into h. So I just add all these things. Now it is clear. So you get the area, and if you put, you will get the area of a heat transfer from a single pin. Now it is clear. Please tell. But this is the single pin, right? So this will be the maximum area. Please remember. Each, if you know this thing, this is the maximum area, na? Just a minute. Let me, for better understanding, I am just putting the value here. The value you got here will be around 0.0027. Up to this it is clear? Please tell. So what we know? Q fin. Just if I know Q fin by Q fin max, this is your N, right? So in the question they asked you to find Q single fin dot, which is N into Q fin max. Why I am using this formula here? Because if you use this area, so you need the surface temperature at this point. Whether this surface temperature is known to you? This surface temperature is known. So only the base surface temperature is known. So you have to use the Q fin max. So which is basically, now you got it? Is it clear? Single fin or at base area into Biplopji, is it clear to you? So why we are using efficiency here? This is because the surface temperature at the end of the fin is not given. If it is given, you can directly use HA into this one, where in place of B it will be TL minus T infinity. So efficiency is given. What is the efficiency? Huh. Yes, yes. Huh. 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 TL. Yes. Actually, if the base temperature is given, then efficiency or effectiveness will automatically come into this picture. But if the site, or you can say the H temperature is given, then this efficiency is not required generally. Okay. So this efficiency value is 0.098. It is given into H is given as 50. It is 0.0027. TV most probably 190 I have seen. 190 degree. This is 190 degree. So this is 190 minus this one is 27. So you will get the area heat. Is it clear? Uh, so just I am writing this area value because I have already calculated this one. So the value that is coming here, this one will be 21.56. This is for single fin. Okay. So I'm just erasing this thing because I have to show you few more things for your understanding. So just tell me. Huh? Yes, corresponds to single fin. Yes, yes. So that one here it is getting 25. This one. Okay. So now my question is that if this is for single fin, if the question is that for fin spacing, sorry, forgot about this thing. So say what is the, if the area you need to find out, just few question you need to answer. Just a minute. So if the question is asked what is the heat transfer, total heat transfer from all the unfin portion per meter length, just giving you this question. So this is the question. You understand this question? Unfin. Unfin means this spacing. In this figure, this one was there, na? This area they are talking about. This 7 mm. What is the heat transfer from this unfin portion? So what is the area? Please first tell me what is the area. Hmm. Pi d1 into h. A unfin or no fin into pi d1 means 0.06, right? Into 0.007. 0.007. So if you calculate, you will get 0.00132. This is unfin. So this is for single unfin. So what is Q? Because the heat transfer from this unfin area directly take place. So there is no efficiency or no effectiveness required. Is it clear? So I am saying as the heat transfer from this unfin area is directly take place from here the convection is directly taking place. So the base area is okay. So you can take the formula H A, yes, Tv minus T infinity. So you will get a value. This is for a single fin. So a single unfin. So how many unfin are there? Unfin portion? 100. So Q unfin into 100 will give you the total, right? Ayush, it is clear. So similarly, in the previous slide, you got Q fin single. How many fin are there? 100. Yes or no? Huh. So you can find out this one also. Question can be asked for the 100 fins. What is the total? And in the even they can ask what is the total heat transfer from the fin section. Total. Huh. Same. It is because the question, because in the question it is given 100 such space is there 100 fins. So we no need to think about that way. It is already fixed way. Huh, huh, yes. Huh, huh, huh. Yes. Yes, but they have already given it as a zero indicated. So that's why we no need to think like that way. Okay. So that means you can find from a single fin, you can find from an unfin portion, total unfin portion you can find out, or also if they can ask you the total heat transfer rate. So what would be that total heat transfer? Cumulative of base and fin. That means this scenario plus this scenario. Q unfin into 100 plus fin into 100. So that will be the total heat transfer. So that question can be asked. So you can easily find out. Another question can be asked. So the question is that mm, uh, what is the increase in the heat transfer rate? So in that case, I will find out what is the increase in the heat transfer rate because of this finning, because of the addition of the fin. Huh, 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 huh. Yes. That means if you say what is the area, just tell me about this area. Whatever you concept you have said, that is totally correct. So for no fin, it will be pi, diameter is h. So in the question, see if you look into this question, no height is given. Directly, whether anywhere height is given, just read the question once. Huh, huh, yes, good. Huh. That means 1 meter. Yes, very good. I wish it is clear. Hmm. Yeah. Whole height. So if you got the whole height, you know the diameter, you have the, so pi dh is the total area. So if you get the area, you can find out the heat transfer, which is HA into TV minus T infinity, right? So so that was, if the fin was not there, that this was the heat transfer. And before this we have already calculated, if the fin is added, how much the heat transfer is there. Uh, 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 yes, yes. So such types of question can be given in the exam. So the main is the fundamental question. Though the formula, many people goes into this formula, that is not always required. It's a simple question. Like in the first case of the fin, we have considered efficiency. Why we have considered efficiency? That is the fundamental we require for solving this question. Many students directly use this formula without n fin, and if you use the equation without n fin, then whole this problem will be wrong. You understand this, everyone? Okay, so that is the thing. So up to this, so I will share with you this concept. Anything, any confusion up to this? Yes, yes. So another question, there is a question at question 4 or 5, which I haven't solved for today, because that is based on this concept of fin, where we have taken this fin, heat transfer is taking at the edge of the fin by convection. You remember this case 4? So based on this, I have few question, two question that I have shared with you. I will share with you. So you please go through this, and similar types of question will be asked in the question. So no need to worry about this. Just understand the fundamental, and the most important thing is that what are the boundary condition. So always, as many of you are from are in BTech, so you have to do this BTech project, or you have to solve some simulation or coding based problem. So you need to know this, what are the boundary condition required to solve a problem. So that is important. The solution may be difficult, but if you know this boundary condition, there are so many software which can do the calculation for you. It is that you will not require to solve the equation, you will just have to give the boundary condition. You give the governing equation, you give the boundary condition. Governing equation means that theta equal to c1 e to the power mx plus c2 e to the power minus mx. Such types of equation I am talking about. And two boundary condition are required for this case. In some cases, three boundary condition is required. So you have to understand this concept. So, Biplabji, your email ID, I just uh, note down this email ID. Uh, not an issue. Actually, I am also sharing my email ID with you. So, so that will be better. Uh, i- huh, 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 huh. Yes, yes. Yes, yes. Hmm, 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 hmm. Yes, yes, yes. Huh. Yes, yes. If you talk about this difficulty level, so I think this angel is a little bit easier compared to other. So, huh, huh, huh. Yes, 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 definitely. Huh, huh. Okay, okay. Hmm, 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 hmm. Yes, yes. So it is from different book. It is not necessary from a single book. What I have seen that 4 to 5 books are taken for these courses. So you will not say from where this question they have given. Okay. Huh. The question concern of question fundamentally yes yes. Uh, yes 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 yes. Yes, yes. So you will follow. I think that you will follow that book. So which will be because if I talk about this angel, so in the angel there is a little bit confusion. If you talk about a question, in this question there is no such. There is a what I can say. There is a lot of confusion in the question. So what is my feeling is that in the Angel, though it is for good for BTech level, but beginners, but there is a little bit confusion there because in this question also I have found some question where they are given this the heat transfer is through convection, but they are using infinitely long fin. So that types of question I have also found. So I think that rather than they are mainly thinking in a BTech perspective, not from the fundamental perspective. Huh. So I have shared the mail ID with you. So please check. Huh, huh, huh. Uh, that- yes, yes, huh. Yes, yes, yes. Generally, that may be the yes, 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 yes. Generally, that will be the that will happen. Maybe in some so that thing, I think that no, it is a relative marking maybe is there. It is not. I am not. It is. It actually depends on. Yes, yes. Matlab whosoever got the highest, he will be considering into the excellent category. It mainly depends on the faculty. How the faculty is because if the question paper is hard, so if someone is highest mark is 70, so it is not like that anyone is not getting excellent. So good. That yes, 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 yes. Hmm. Yes, yes. I am in my final year. Yes, yes. I am from IIT Bhubaneswar. Hmm. huh, huh. Yes, yes. Hmm. Yes, yes. Huh, huh. Hmm. Yes, yes. Hmm. 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 Yes. So, see, just a minute, huh? So I'm answering. Actually, I have to off the recording. Just a minute. Okay. Thank you.